name is Muhammad Fawaz bin Hashim, metric number CN190136. Okay, the purpose of this video is to explain summary for the entire semester in semester 2 for sesi 2020/2021. This summary is for subject BNE22103 Programmable Logic Control PLC, and our lecturer is Cik Sumayyah binti Masuri, and we from group C. Okay, next I will introduce our group member. First person is Wan Abdul Azim bin Wan Muhammad Fauzi, metric number CN190149, and second person is Muhammad Fawaz bin Hashim, metric number CN190136, and third person is Iqbal bin Safa'at, metric number CN190215. Okay, next we go to our objective to ensure that all group member understand what is being taught by the lecturer from week 1 until 40. Ini sangat penting kerana pelajar boleh mengimplikasikan apa yang telah dipelajari di alam universiti dalam subjek PLC ini. Mereka boleh gunakan apabila mereka telah berada di dunia pekerjaan. Contohnya sekiranya mereka bekerja di kilang-kilang yang banyak menggunakan PLC sekarang ni. Okay, next student are able to correct error in PLC subject. Okay, pada part ni juga penting kerana pelajar juga dapat mengesan kesilapan yang terdapat di dalam PLC subject ni. Okay, next student be able to solve technical problem in Omron software. Okay, pada part ni kita telah menggunakan Omron CPIE type E20. This Omron have 20 input and 12 for input and 8 for output. Okay, we go to our next video. Leader diagram kerana dia merupakan penyelamat yang terawal sebelum penyelamat lain datang. Contohnya sekiranya berlaku kemalangan tersepit jari ataupun apa-apa yang tersepit lah, push button ni dapat mematikan dita yang tengah berfungsi. Contohnya conveyor, tangan yang tersepit conveyor, dan tak semena-mena nyawa si pemangsa dapat diselamatkan dengan secepat mungkin. Push button stop ni juga dapat mengelakkan daripada berlakunya kebakaran. Contohnya sekiranya terdapat motor yang high amp yang menyebabkan panas, dan push button ni berfungsi untuk mematikan lita sebelum kejadian yang lebih buruk berlaku.
Assalamualaikum, my name is Wan Abdul Azim bin Wan Muhammad Fauzi. Today I want to present about the activity in the week 1. So firstly, we have been introduced about the food activity in this course for this subject. Second, we have invited to the webinar on the industrial talk by the Festo Didactic. So after the talk, industrial talk, we have been given one assignment that we should do a mind map based on the topic on the industrial talk. So this picture is an example of the mind map that we have do. So for this mind map, we have the introduction to company, Festo Didactic, and advantage of the hydraulic, and so on lah. So next is in the week 2, we have been given a lesson plan via online, because in this semester we have been uh, uh, we have been study in the online, not by the face to face. So next is a PLC activity on the previous semester. So this have a 3 picture. First picture is the uh, in BNE SEM 2 2018 and 2019, the previous semester. So we can see that the previous semester they can be studied by the face-to-face. So the first picture is a wiring mentor-mentee program. Second is the group PLC application on the BNE. And the third picture is a BND, also the PLC application. So the next is in the week 3, we have been familiar with the Omron CP series, CP1E CPU units that have a PLC system, input-output memory area for the CP1E. Second is understand the feature for the CP1E, E20 and the CP N20 models. So the first picture is the PLC system. So what we have here is a power supply on the upper side, and the left side is the input module that have connect by the input sensing device, such as uh, example push button, stop button, and so on. Uh, and at the middle is we have a memory program data that have a central processing units that we call the CPU, and the right side is the output module that be connected to the output load device, such as lamp, conveyor, and so on. So at the second picture, we can see that the input-output memory area for CP1E. Firstly, for on the first is the input bits starting from CIO 0, and this user area that include the work area, holding area, DM area, timer area, counter area, and the last is the output bits starting from CIO 100. So at the right side is the system area that have a auxiliary area, condition flags, and clock pulse. So next is the activity in the week 4. We also given a familiarization with the PLC Omron CP series, CP1E CPU units that have two models. First is CP1E E20, and the second is CP-N20. So next is identify the PLC model. Based on the model number structure, we use the CP1E. Firstly, class. E is a basic model, N is an application model, and A is an application model with built-in the analog. So they have a difference between the E and N. So second is a I/O capacity. So we have a 10, 14, 20, 30, 40, 60 based on the model type. So we use a E20 or N20. So we should focus on the 20 I/O points that given 12 for the inputs and 8 for the output. So 3 a unit type. S is a renewal, non is a normal, 4 built-in RS485 port, and then the 5 input type. D is a DC input, not the AC. 6 output type. R is a relay output, T is a transistor output syncing, T1 transistor output sourcing. 7 a power supply. A the AC power supply, and D is a DC power supply. They support both AC and DC power supply based on the model. So next is a input-output terminal arrangement for CPU unit with the 20 I/O points, AC power supply model, CP1E model. So for this picture, on the upper side, we can conclude that this is a input. They have 0.0, 0.01 until 0.0 until 0.11 for the inputs, and for the output we have a 4 COM and 2 normally closed. So the address for the output is starting for 100.00 until 100.07. So that's all for me. Thank you.
Okay, next we go to week 5. We have learned about ladder diagram. Why we call ladder diagram? Because resemble a ladder diagram with 2 vertical bus bar. Okay, this is a vertical bus bar. This for 24 volt VDC, and this is 0 volt VDC. Okay, this is setting from CP1E X E20. This part we learn about how to know rung, step, and output. This 0 at the top is we call rung. 0, 1, 2 is rung, and this is for step 0. We start with rung 0, and next step is 4. We start at rung 1, and next step is 8. We start at rung 2. Okay, for input, for load 0.0 is step 1, and next we must to know the vertical of PLC. This is left to right and top to bottom. Okay, for this case we must know from top is this will be step 0, and for the bottom is step 1, and the next is step 2, and the output is step 3. And we go to round 1. We start with step 4, and the bottom is step 5, and the side is step 6 and step 7 for output. Okay, we go to round 2. At the first load is step 8, and the next is step 9, and the output is step 10. Okay, next before we go to our basic ladder diagram logic instruction, we must know the inputs for CP1E type. Okay, we use for this PLC Omron CPIE type E20 that have 20 input point, 12 for input and 8 for output. Inputs input must 0.00 until 0.11 for channel 0, and for output is 100.00 until 100.07 at channel 100. Okay, next we go to our basic ladder diagram logic instruction for week 5. First we can see load this caused because they are connect with 24 volt disconnect 24 VDC, and this is normally open, and it will be load. And next is load not. This happen because load is connect to 24 volt and dia bertemu dengan normally close, and will be load not, no contact, normally close contact. Okay, next and not. This is series connection. This is normally open, connect with normally close, and at the center for series connection is and dia bertemu dengan normally close, will be and not. Okay, next is and for series connection, and they have no not because all the connection is normally open. Okay, next is or. This is condition parallel connection. Okay, why be or? Because at the junction of the connection must be or. Okay, next or not. Why or not? Because the connection parallel is connect with normally close, so it will be or not for parallel connection. And next, OLED. Why OLED? This is for parallel block. We must divide into two block. This is for the top is block 1 and the bottom is block 2. After we summarize, and we get all load. Why be all load? Because after we summarize, before we summarize, we must to list out the load, and we will be all load. Okay, next is and load series block. Okay, this is for block 1 and this is for block 2. This is parallel. After we simplify, and it will series connection, and at the center will be and connect with load, with no not because they are because there no connection with normally close at there. Okay, next is for output. Must connect for 0 VDC. Sekiranya tidak disambung kepada 0 VDC, dia akan error lah. Okay, next. Okay, next we go to mnemonic code. How to build mnemonic code. This is first diagram. This load is connect to 2 bus bar 24 VDC, and this is 0. For address is I will take 0.00. Okay, first we must know is connect to 24 volt, it will become load, and the address is 0.00. Okay, next is load not, will be mnemonic code. Load is connect where dia terjadi load kerana dia connect kepada 24 volt and contact to normally close contact. Okay, next. In series connection, this is the bus bar 24 volt 0. Okay, first this address I will 01. Okay, for first we write load 0.00, and this is series connection. It will become, and dia bertemu dengan normally close, it will become not, and for address 0.01, and after that it will become a not because this is a series connection. And next series connection juga. Okay, load 0.00, and this is normally open, it will become n. There's no not because there are no normally close. Okay, next for parallel, is connect to 24 volt and address 0.00, and this address 0.01. Okay, this connection we must know the PLC law. It must look left to right and top to bottom. Okay, for the first we must write load 0.00, and the bottom load is 0.01. This connection is parallel, and this is OR, so it will become OR. And while load, because this load and this is load, it will become OR load. Okay, next or not. This connect to 24 volt and address 0.00, this address 0.01. Okay, first we must know is normally open, load 0.00, load not at the bottom, load connect to 24 volt, and not because it is normally closed. And after we simplify, will become all load because this is load and this is load. Okay, next this is parallel block. Okay, it will divide into two block. This is top for block 1, bottom is block 2. For block 1, we must to simplify this first. Okay, for the first load, address 0.00, and it is series connection, it will be in address 0.01. And for block 2, load 0.02 for address and series connection 0.03, and after combine it will be like this. So it will be all load. Okay, next is series and load. Okay, this is divide into two block. This is block 1 and this is block 2. First we must to know how to simplify for block 1. We write load go to address 0.00, is parallel, it will become OR. And for the second block, this is same like block 1, load address 0.02, and it parallel, it will all load or sorry, after combine it will become like this. Okay, and it will be a series connection, and it will be n because series. And load is, this is load and this is load, it will become load. Okay, in this part we learn how to write the mnemonic code in the table. Okay, first we must know rung, and we must know step. For the rung, we can look at the left side. It will in the CP1E programmer. Okay, for the table we must write the rung, and this is for the step. We must know what step this like this is first step, second step, third step, and fourth step. Okay, for instruction we must know the label, like this is load, and whatever it will become berubah-ubah berdasarkan dengan soalan. This is operand at the load, or the label at the top of the load, and the command at the left side at the blue color, this for the command. Okay, next is basic logic function in week 5. This is AND gate. From this we must do full the truth table, and we need to draw the ladder diagram. Okay, from our information we must to draw the information, draw the ladder diagram first. This is input A, and this is B for input, and cylinder is for the output. Okay, after we draw the ladder diagram, load A and connect with load B and connect with output to 0 volt. Okay, for mnemonic code, after we draw the ladder diagram, first load is A, is connect to 24 volt, and this is a series connection, and it will be N B, and followed by output cylinder. Okay, next is OR, gate OR. Gate OR is mean in parallel connection, like this. Wait, okay, this is for A, and bottom is for B. Okay, now we must to draw the ladder diagram for our gate. A is at the top, and B is the bottom, and the cylinder is for the output. Okay, after we draw the ladder diagram, we must write the mnemonic code. First is load, and because it is connect to 24 volt, and next follow with OR. This is because it's in parallel connection, and followed by output cylinder. Okay, next is NOT gate. NOT gate will be whatever input, it will become bar at the bottom of the input. Okay, it is a NOT gate, so it will be like normally closed loop. Okay, for ladder diagram, connect to A and output cylinder. For minute code, load not A, load not because load is connect to 24 volt, and not because it is normally closed connection, normally closed load, and followed by output cylinder. Okay, that's all for week 5. Okay, next we go to week 6, which membuat latihan berdasar dengan apa yang telah diajar pada minggu kelima. Okey, berdasarkan kefahaman saya dan kumpulan saya, kita perlu membuat diberi logic gate dan perlu ditukar kepada boolean expression. Okay, this is OR gate, and this is OR gate and AND gate. Okay, berdasarkan pengetahuan yang telah diajar oleh pengajar, apabila OR dia akan menjadi parallel, dan apabila AND dia akan jadi series. Okay, for OR, this A and B is for input. It will become A plus 4, and this input C and D, it will become C plus D. For our information, or it will be plus, and this gate and it will become multiply. Okay, after we get the two input, okay, we must know this is no gate and it will become E. Okay, after we get the three input for AND gate, and we must to combine it, A plus B. For gate AND, it will become multiply, and C plus D, and it will multiply with E. After we multiply, we get the output, and this is the ladder diagram. A parallel with B for OR gate, and C parallel with D for OR gate, and E nothing. They in series connection because there is input for AND gate. AND gate is series, and OR gate is parallel. And after using CPIE CAD programming, this become like this and like this. Okay, next, for week 6, we also have learn case study. For case study, we need to read the question and fahamkan question, and we must to identify what is input and what is output. Okay, next, we need to isi the truth table berdasarkan boolean expression. Okay, next is draw the ladder diagram. Write with hand or CAD programming. Okay, that's all for week 6. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Iqbal bin Safaat. My metric number is CN190215. Today I would like to present about the syllabus that we learn in week 7. On week 7, we learn about the PLC instruction on PLC program. And this first page, we see on the CX programmer, we learn about this is the rung and 24 volt. We use the CP1E program, the rung number, and this is 0 volt, and this is the instruction, and this is the input. The second picture, we see the syntax error that we learned, and this is for timer. The input is from 000 to 255. We cannot use 600 and above, or above 255. We can use in the range of 000 to 255. And the third picture is the show about how we convert from the program to the hardware. And this is the instructor we can use to do it. And the fourth picture, we can see the input signal for this button, and the second switch for this button, and this is output. And then the line is connected, the lamp will show. And the sixth picture is about the test, how we can know the program is running. Next is the mistake on program that student regularly do it. And for this, the student is mistake on the input and output. For the input, source is 0.00 until the 0.11, and for the output is 100 to 100 to 100.07. And this is the right answer. And this will show that how the current flow. The current will flow, but when we go to the hardware, there is problem in here. Okay, next. We can know the type in here in the program. On the program, we can know that this is the pause ladder diagram that we know, and how to fix this is here. When this is for the normal latching instruction. Next is on week 11. We on the industrial talk on PLC and SCADA application from industry perspective and experiencing sharing. For the panel 1 is Muhammad Syukur Abdul Rahman, the alumni on BND, and the second is Natasha Amirah binti Abdul Rauf, also alumni from the BND. The moderator is Kalai Mutan, anak lelaki si Bahasa Mugam from BND, and he is in year 3 now. Okay, next. On week 12, we had the self-learning based on example from the lecturer, and this 3 picture is some of the example from the lecturer, and how we can understand this simple narrative is for the number one, start from input, start button is pressed, and we go to the output, motor will start running, green lamp will be turned on, and the second is sensor detected the box, motor will stop, and the green lamp will turn off, and red lamp will turn on. And the third step is the emergency stop button is pressed, motor will stop. And we can know here. This is the ladder diagram for the PLC conveyor motor. And next, we go to the hardware connection on trainer. This is the trainer for the PLC, and for the second picture is the wiring design in the PLC, and we know this is the input switch and this is the output switch. This is the output indicator. Okay, and the third is how the one on the lecturer using the switch 1.
Assalamualaikum, I'm back. So what we want to discuss in this slide is what is a normal latching and keep instruction. So I choose this topic because in the beginning of the SEM, I have not recognized what is a normal latching and the keep instruction. So firstly is a normal latching. The normal latching is used where the output must be activated even after the entry cases. A simple example of such a situation, I give a one motor which is started by pressing the button switch. So for the normal latching ladder diagram given, we have here is a start button as a normally open and stop button as a normally closed. So we have the internal relay as a 10.00 the address, and normally open with parallel with the start button. So uh, the process, when we press the start button, automatically the current will flow through the internal relay. So when we unpress the start button, the currents remain flow through the internal relay because we have the contact normally open here that parallel with uh, the push button start. So when this internal relay activated, this automatically with the active height, so the currents remain flow through the internal relay. This for the normal latching. So we go to the keep instruction. In this keep instruction, we have to use the set and reset instruction on our PLC program uh, for the many rungs. For using a set reset, we have to write this instruction at two different rungs, and for every bit and has set it has to reset at some condition. So in this ladder diagram, what we can see here, we have a normally open start that connected with the set, and the stop button known as a normally open we connected to the reset. So when we start when the start button in the active height, the current will flow, the keep will energize, so the keep will in the high state. So it will remain the current will active. And then after we press the stop button here, automatically the current will stop flow because at this line is connected to the reset. So for the conclusion for this topic, I can conclude that for the normal latching and the keep instruction are same function, that can be uh, can be flow the current when we press and then we unpress the start button. So they will keep the current flow until we stop the button. For the keep, we stop we stop uh, we stop the button, then we do, then we it will be reset all the program. So for the normal latching, when I press this stop button, it will be cut uh, the current flow. So the internal relay will be de-energized, or the will be low, so no current flows. That's all for me. Thank you.
Now I will teach how to write the monolithic code program instruction. And this is for the round 0. And for the S1 here is step 1, LD not. Operand is here 0.00. Command is S1. For the step 2 is N not, and the operand is 0.01 and the command is S2. And the step 3 is N, because this is normally open, and the operand is 0.02 and the command is S3. And the step 4 is LD, because it is normally open and the operand is 0.00 and the command is S1. And the step 5 is N not, because it is normally closed. For the operand is 0.01 and the command is S2. And for the step 6 is N not, because this is the normally closed and the operand is 0.02 and the command is S3. And the step 7 is to OLD, because this is the OR connection. And the step 8 is output is operand 100.00, the command is V2. That's all from me. Thank you.
Okay, Assalamualaikum. Bertemu lagi kita. Okey, pada part ni saya akan menerangkan part yang saya kurang faham pada awalnya, iaitu pada test 1 berkenaan dengan case study. Okey, apabila kita mendapati soalan berikut merupakan soalan case study, pertama-tama sekali kita perlu baca dia punya soalan. Contohnya ni soalan test 1. In a chemical processing facility, liquid chemical are used in the production. The chemical are stored in 3 different buffer tank. A level sensor located in each tank give a location height signal when the level in the tank fall below a lower limit. Assuming the 3 level sensor A, B, C and the alarm signal from the circuit is F. Okey, berdasarkan ni ayat-ayat ni, kita perlu mengenal pasti yang mana input, yang mana output. Okey, setelah mendapati yang mana input dan output, kita senaraikan input iaitu level sensor at tank A, B, C. Kadang soalan dia nak tree ni dia label untuk kita pergi berfikir panjang untuk mendatangkan masalah kepada kita. Sebenarnya benda yang sama diletakkan di dalam tangki yang berbeza, dia punya operation yang sama. Okay, we need to simulate this problem by using CPIE E20 with input signal 0.00 until 0.11, for output we using channel 100 for range 100.00 until 100.07. okay, after we know the input and output, and from the question, he said analyze the alarm signal condition for active height and use the truth table to support your evaluation. Okay, this part we must to draw the truth table lah. Okay, for the left side is for input and for the right side is the for output. From the operation, when the level water is dropped, the level sensor will function and the output also function. And when water level is now drop, the water level sensor cannot function and the output also cannot function, 0. Okay, from the question test 1, describe the logical Boolean expression from the truth table. Okay, if level sensor at the 3 tank ABC is false, low, output or alarm signal should also false. It means if level sensor give low signal, alarm should not operate. Okay, alarm tidak akan berfungsi sekiranya level sensor give signal yang rendah, kiranya tak ada input, 0. If level sensor at the 3 tank ABC is too high, output or alarm signal should also true. It means if level sensor give a high signal and alarm will operate. Okey, yang ni terjadi apabila air mendapati turun mendadak ke melepasi alarm sensor ni, ke level sensor, alarm akan beroperasi. Okey, seterusnya soalannya, draw a ladder diagram for the Boolean expression. Okey, before we draw the ladder diagram, we need to know the level sensor initially is normally open. So level sensor dia tak akan normally close lah. Okay. From the ladder diagram, I draw by using AutoCAD. This is bus bar for input 24 volt VDC and the output 0. VDC. Okay, this part is we call condition input and this part we call action or output. For condition or input, it is a level sensor and the output is alarm signal, or we call output at the 3 tank mean A, B, C. This ladder diagram is same because it only a different huruf, but the operation is same. This is trick from the question. Okay, that's all for me. Thank you.
And now we will continue for the detailed explanation on progress and technical solve. And this is the problem that we would solve for the conveyor, counting object on the conveyor. And this is the simple narrative of counting object on conveyor using PLC. The sequence, input and output. Step 1, push button start is pressed. Buzzer will on for 5 times and the counter 1 count for 5 times and the conveyor 1 will on. Sensor 1 detect item 1 active and flow to conveyor 2. Counter 2 will count 5 times, and for the step 4, counter 2 count 5 times conveyor 1 off, conveyor 2 on. Step 5, sensor 2 detect item 2 active and flow, counter 3 count 5 times, and step 6, counter 3 count 5 times, continuously looping. And for the program will continuously looping. And the step 7, push button stop, press when the conveyor 1 on, the conveyor 1 off automatically. Step 8, push button stop, press when conveyor 2 on, the counter still count for 5 times. Step 9, the timer on for 15 seconds, the conveyor 2 will stop. And step 10, emergency stop button is pressed, conveyor 1 and conveyor 2 will stop automatically. And I will show you the diagram and the work online simulator. Let's go. And from here we can know the ladder diagram here. And now we will compile this ladder diagram, and it show no error and no warning. And now we will go to work online simulator. And now you can see the work online simulator is on, and we will push the start button and release it. Buzzer will on 5 times, and conveyor 1 is on for 5 times, and conveyor 2 will count object on conveyor 2 for 5 times here. And this program will be looping for unlimited time unless we push the stop button. And there is 10 seconds and off. But 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 when we push the emergency stop button, and now we will start with the troubleshoot error in PLC. First we will be to the keep instruction. For this instruction, we know there is a problem here. We can see the the rate, and there is a problem, and there is one error on the wrong one. Okay, how we can know? We use the PS instruction CP1E, and we go to define the keep instruction. For the keep instruction, we can know it will be the connection for set and reset, and here is wrong. And how we try to start again is to cancel this and use the and we use the here. How I can know is for the keep instruction we will be two normally open for the push button stop, and here we compile the file and no error and no warning, and go to work online simulator. And then we push the start button, and release it. The keep instruction will be act to the normal latching, and motor will be on, although we doesn't press the start button anymore. And to stop the motor, we will be press the stop button here, and the motor will be turned off. And next we use the timer instruction. For the timer, we can know this. Go to theme, and for timer, the limit is 000 to 255. We can use although the 100, 200, and not above the 255. For here, we use the 255, But if we change to 300, the red to the wrong one will appear, and we get the one error. And if we change to the 100, 199, compile, there is no error. And if we, for this program, push button start, the normal etching is on, the normal etching will hold, the timer will be run for 10 seconds, and the motor will be off. We can see here. Go to our online simulator. Connection is grow, and when we push the start button, and release, the timer will act for 10 seconds. Up for the motor, after 10 seconds, the motor will be turned off. Oh, sorry, we're not matching here. Why it didn't turn off? Because this is not matching. To matching this, we use the T199. Yeah, we run again. For here, we push the start button and release it. The timer will be for 10 seconds, motor will be on, and after 10 seconds, motor will be off. Okay, that is for the timer. And for the last is counter instruction. There is the counter program here. When you push button start, the internal latching will on, the latching will be on, the pump will on, and when after 10 seconds, the pump will be off and the timer will be on. The counter will be running for this program for 5 times here. For the counter, there is no limit here because we can see here for the counter there is no limit. And for the count input is here, and reset input is here. We can know here. reset input after 5 count, the program will be stopped. We try compile, there is no error and no warning. Go to work online simulator. And the work online simulator is running on. Push the button start. Current flow, wtching here. The timer will be count for 3 seconds and the count will be start again for 3 seconds. After 5 time, the program will be reset. Okay. Thank you for this session.
Okay, untuk part last iaitu suggestion, saya berharap agar cik semuanya bertukar platform untuk menyampaikan maklumat kepada pelajar, iaitu menggunakan aplikasi WhatsApp, kerana dengan menggunakan Telegram pelajar kurang alert sebab Telegram bukan main untuk bersosial. WhatsApp lebih alert kepada pelajar. Dengan penggunaan Telegram, dengan kurangnya alert pelajar kepada Telegram ni, dia banyak ketinggalan maklumat. Contohnya terjadi juga kepada saya sendiri dan ahli kumpulan yang lain lah. Okey, seterusnya berkenaan dengan industri talk. Industri talk yang sebelum ni input yang sangat bagus. Seeloknya perbanyakkan industri talk berkenaan alumni ataupun pekerja alumni yang telah berkhidmat di kilang-kilang. Mereka boleh memberi pendedahan yang banyak kepada kita kan, sebagai student ni. Dapat input yang sangat bagus. Pelajar sebelum ni tidak tahu pun sekadar tu kan. Setelah mendapat pendedahan tentang sekadar melalui alumni tersebut, berkenaan pengetahuan ingin mengetahui sekadar tu membuatkan pelajar tidak sabar untuk mengetahui sekadar ni. Okey, setakat itu untuk group 6. Sekian, terima kasih.